Welcome back to the Deep Dive. Today, we are taking on a really interesting benchmark. It's for the future of AI engineering, really. The NVIDIA Agentic AI LLMs Professional Certification, the NCP-AAI. And this one, well, it isn't just about knowing facts. It's about proving you can actually design, build, and importantly, deploy these next-gen autonomous intelligent systems.
That really is the critical distinction, yeah. This professional credential, it validates that ability to move past, say, simple RV systems. It's about managing sophisticated, production-ready, multi-agent workflows, and, the complexity there means info overload is almost guaranteed.
Totally. It's a lot to take in.
Which is why our mission today is to create a more structured kind of interactive deep dive, help validate your core knowledge, and maybe pinpoint where you need to focus study time.
Right. So we're essentially turning the official NVIDIA prep guide into, like, an audio quiz. It's designed to stress test your grasp of the key concepts. But hang on, before we jump into architecture and questions, let's define the shift here. We're not talking basic chatbots, are we?
No, not at all. Agentic AI, it's a system that uses an LLM as its core reasoning engine. That's the heart of it. And crucially, it autonomously understands a complex multi-step problem. It then breaks that problem down into manageable subtasks, plans the sequence, and then this is key, executes that plan, uses external tools, APIs.
So it's like an LLM with hands and a brain that keeps learning.
Exactly. It's got that continuous learning mindset built in.
Okay, great definition. Let's unpack the core mechanics then. If you understand this continuous four-step cycle, you pretty much understand the agent's life cycle. It starts naturally with sensing its environment.
Right. Step one is perceive. This is the agent gathering and processing data. It's, ingesting stuff from databases, sensor feeds, maybe user interfaces. It needs to fully grasp the current context of the problem.
Which then feeds into the brain of the system, reason. This is where the LLM really takes center stage. It's the central orchestrator. It interprets the data from perception, figures out a strategy, creates a step-by-step plan.
And then the rubber meets the road with act. The agent actually does things, executes the plan. This means integrating with external tools, software via APIs, could be running a search query, maybe writing and executing some code, or even processing a transaction.
And then maybe the most important step, especially for governance and evolution. Learn. This is that continuous feedback loop, the data flywheel you hear about. The outcomes of the agent's actions, they get fed back into the system to refine the models.
Exactly. So the agent improves, adapts over time, ideally without constant manual retraining.
Can you ground that with an example? Maybe in software engineering?
Sure. Think about software engineering. An agent could perceive, say, a bug report from a system. It could then reason about the steps needed to debug it, maybe find the faulty code. Then it would act by, pulling the repo, trying fixes, testing them, and finally it would learn from whether the patch worked or not. That's autonomy driving real productivity.
Okay, yeah, that makes it much clearer. That's where it gets really interesting, isn't it? So now that we've sort of nailed down theory of that core cycle, let's see how well that translates. So basically to the architectural decisions you face in production, we're diving into quiz round 1. This focuses on conceptual design, cognition, safety. These areas carry pretty significant weight on the exam.
Okay, get ready. This is where that 1 to 2 years of practical experience really comes into play. It helps distinguish between the conceptual choices.
All right, quiz question 1. It's about cognition and context. So when you're building a conversational AI agent, one designed for sustained multi-turn interactions, you need to ensure it maintains accurate context and continuity. Which reasoning pattern should be implemented? And maybe why is it better than more reactive patterns? Your options are A, react, B, chain of thought, or COTI, C, tree of thoughts, D, good old rule-based reasoning.
Okay, the correct answer here is B, chain of thought, CFT.
Interesting. I could see how someone starting out might lean towards react. Reason and act, it sounds so direct. Why must we choose COTI for maintaining that deep, multi-turn context?
Well, react is great for immediate tasks, right?
Yeah.
Reactive stuff, like agent needs to find an answer, act once, done. But COTI, it forces the agent to establish a logical sequence of steps. It basically makes the agent show its work across different turns in the conversation. By maintaining that sequential thread of thought, COTI guarantees continuity. It stops the agent getting lost or forgetting what was said earlier. Absolutely critical in sophisticated dialogue.
Got it. Makes sense. Okay, next up, complexity. Collaboration between agents. Quiz question 2 is about multi-agent frameworks. you're tasked with developing a system. Specialized agents have to collaboratively plan, assign tasks, execute a big project. What framework is specifically designed to manage this kind of coordination and workflow? Options: A, chain of thought reasoning; B, React reasoning patterns; C, Crew AI framework; D, tree of thoughts exploration.
The answer you're looking for is C, Crew AI framework.
Okay, that one feels maybe a bit more obvious from the name, but
Yeah.
if CoT is good for planning sequentially, why can't we just, like, daisy-chain several CoT agents together?
Because that would lack true coordination. Crew AI isn't just a reasoning pattern, it's really an orchestration framework. It defines roles for the agents, manages how tasks are delegated, and makes sure the output from one specialist agent gets correctly routed and used by others. When you're dealing with collaborative execution, you need something built for coordination, not just linear thinking.
Right, orchestration, not just sequence. Okay, let's talk memory, the engine behind sophisticated reasoning. Quiz question 3 concerns knowledge and memory. To integrate a memory component, one that lets an agent recall past interactions efficiently and draw complex contextual connections, which design approach is most effective? Options: A, implement a simple short-term memory queue; B, use a recurrent neural network, RNN; C, integrate a knowledge graph; D, employ a rigid database system just to log interactions.
For this, you have to go with C, integrate a knowledge graph.
A knowledge graph. That sounds inherently more complex than just logging data in a database, doesn't it? What's the scalable advantage? Why is it the preferred method in this certification context?
The advantage is a relational context versus just sequential context, you see. A simple database or a queue, they just store interaction history in order, like a list. A knowledge graph, though, it stores information as interconnected nodes and edges. Relationships. This structure lets the agent draw complex, nonlinear connections between maybe a past event, a specific user, and a later interaction that seems unrelated at first glance. It just makes the agent's memory exponentially more sophisticated. And it scales better for nuanced reasoning.
Okay, powerful stuff. Final question in this round. It focuses on responsible AI, a really significant part of the exam blueprint. Quiz question 4, safety and ethics. What is the recommended proactive approach to align with best practices for safety and ethics during agent development? Options: A, rely solely on post-deployment monitoring; B, embed ethical guidelines directly into the agent's decision-making algorithms; C, use an external rule-based system to override unethical decisions; D, just focus on optimizing agent performance metrics. The most robust answer, the one emphasizing proactive design, is B, embed ethical guidelines directly into the agent's decision-making algorithms. That distinction between proactive and reactive seems crucial here, right? Why not just rely on an external override system like option C?
Well, relying on an external system or just monitoring after deployment, it's reactive, it's cleanup. If the agent makes a bad, maybe even malicious decision, the external guardrail might catch it, sure. But the damage could already be done. By embedding the guidelines, think constraints, guardrails on behavior directly into the LLM's decision process itself, well, you ensure ethical considerations are fundamental, right from the planning and reasoning steps. It makes the system more likely to fail gracefully or avoid the harmful path altogether, rather than needing to be caught after the fact.
Okay, let's pause for a sec and talk strategy. If you found those questions a bit tricky, well, that's kind of the point. This is a professional exam. It really requires serious production-level experience. Passing isn't just knowing the answers, it's understanding the common failure modes in these systems, why things break.
Exactly. The biggest weight areas are agent architecture and agent development. That's 30% combined. People often fail not because they don't know the definitions, but because they can't handle those tricky production-level questions about why a certain architectural choice might lead to failure down the line in deployment.
Right. That's why you really need to move beyond just reading the docs. Preparation has to be structured, targeted, and reflect the adaptive nature of the exam itself. You have to, well, practice smarter, not just harder.
Yeah, absolutely. You should look for tools that cut out the inefficiency. For instance, a really good preparation resource like, say, FlashGenius will offer something like an AI-guided learning path. What that means is you don't waste time reviewing basic R concepts if you're already solid there.
All right, it adapts to you.
Exactly. The path adapts to your goals, focuses your precious time on the tough areas, like advanced multi-agent coordination or platform deployment configurations. The topics where real-world experience is often the only difference between passing and failing.
And probably the most valuable part of smart practice is learning from your mistakes, isn't it? A truly effective study tool needs Something like an AI-powered smart review feature.
Definitely. It shouldn't just tell you, oops, you just went 5 wrong. That's useless.
Yeah, it needs the why.
It needs to analyze why you picked the wrong reasoning pattern or maybe the wrong Triton configuration. It should give you a targeted explanation linking it back to a known architectural pitfall or a common mistake others make. Honestly, learning from those collective mistakes, it's a massive shortcut to earning this certification.
Okay, strategy covered. Let's shift our focus now from theory to actual deployment. This round dives into the NVIDIA stack, specifically Triton Inference Server and TensorPat LLM. These are absolutely essential for the platform implementation domain on the exam. How do we take these complex agents and deploy them efficiently at scale?
Right. This section really separates the architects from the hobbyists, let's say. It's all about low latency, high throughput scaling.
Okay, quiz question 5. Deployment and scaling focus. You're deploying a high-traffic agent using NVIDIA Triton Inference Server to ensure optimal scaling and redundancy efficiently. What's the best practice? Options. A, deploy using just a single instance but with lots of memory. B, utilize model ensemble features within Triton. C, implement load balancing across multiple Triton instances. D, use a single GPU, just cranked up to maximum power settings.
The core scaling practice you need here is C. Implement load balancing across multiple Triton instances.
Okay, why is that horizontal scaling, using load balancing, so much more effective than just throwing a massive single instance at the problem? Option A.
Well, a single high memory instance, no matter how big, it's still a single point of failure, and it will inevitably hit a performance ceiling under high concurrency. Load balancing lets you distribute the processing load across an array of instances. That ensures efficient resource use, plus it gives you that necessary redundancy. It's just standard practice for any serious enterprise-grade deployment.
Makes sense. Avoid bottlenecks. Okay, next challenge. Latency. This is the absolute killer for any real-time agent, right? Quiz question 6. Latency optimization. An agent's response time is way higher than expected during production deployment. Which optimization strategy is most effective for drastically cutting latency, specifically on NVIDIA hardware? Options. A, increase the batch size. B, enable model ensemble. C, utilize TensorRT LLM for model optimization and faster inference. D, switch to a CPU-based deployment. Probably not.
Yeah, definitely not D. The answer is C. Utilize TensorRT LLM for model optimization and faster inference.
Interesting. A lot of optimization tricks involve increasing the batch size. Option A. Why might that actually be counterproductive if you're fighting high latency in an agent?
It's a classic trade-off. Increasing batch size generally increases throughput, like the total number of tokens processed per second. But it often comes at the cost of increased latency because individual requests might have to wait longer for the batch to fill up. TensorRT LLM, on the other hand, it optimizes the model graph itself. Specifically for the NVIDIA GPU architecture, it drastically reduces the actual inference time per request. And that's the direct path to the low latency you absolutely need for real-time agent interaction.
Gotcha. Throughput versus latency. Okay, let's tackle throughput and managing tons of parallel requests. Quiz question 7. Concurrency management. An engineer needs to optimize a Triton inference server deployment. It has to handle, say, thousands of concurrent user requests efficiently. Which specific Triton feature should they leverage? Options. A, deploy the model on a single GPU only. Use model ensemble techniques. C, leverage Triton's dynamic batching. D, implement a sequential queuing system.
The key optimization technique here is C, leverage Triton's dynamic batching.
Dynamic batching. That sounds like a powerful, maybe proprietary feature. How does it manage to improve efficiency in these high concurrency situations better than just standard parallel processing?
So dynamic batching lets the server intelligently group multiple incoming requests together. Even if they arrive asynchronously at different times, it processes them together in one optimized GPU pass. This maximizes GPU utilization, keeps the hardware busy. It ensures the GPU isn't just sitting idle waiting for one request at a time. And that translates directly into higher throughput and much smoother handling of concurrent loads.
Very cool. Okay, final question for this round. Even with the best setup, things go wrong. Monitoring and diagnosis. Quiz question 8. Platform monitoring diagnosis. During monitoring of your deployed agent, you observe unexpected persistent latency spikes. What's the most effective first step to diagnose and address this specific issue within the Triton environment? Options. A, increase the server's memory allocation. B, review the server's dynamic batching configuration. C, switch to a higher precision model. D, use the AIQ toolkit for real-time logging.
The most targeted first diagnostic step is almost always B, Review the server's dynamic batching configuration.
Ah, that seems to be a recurring theme. Such a common failure point. Why is the dynamic batching config the immediate go-to before you start blaming hardware or memory?
Because if that dynamic batching is misconfigured, like maybe the maximum queue wait time is too long or the max batch size is too large for the actual concurrent load you're seeing, it will directly lead to those periodic, unexpected spikes in latency. The system struggles to assemble and process the batches efficiently. It's very often a configuration issue, not usually a fundamental resource issue like memory. So checking that config is the most logical and usually the lowest cost place to start debugging those spikes. Hashtag tag outro.
And that wraps up our pretty intensive deep dive quiz into the NCP-AAI. Just to recap the basics, this is a professional level exam. It's 90 minutes long, typically 60 to 70 multiple choice questions. Costs 200 LSUs, and the certification is valid for 2 years.
Yeah, and the main takeaway I think remains this. Focus your study time where the complexity is highest. That's agent architecture, agent development, and really understanding the practical nuances of deployment using Triton and TensorRT-LM. Passing this validates your mastery of the entire, cutting-edge multi-agent workflow. It earns you a badge that speaks directly to what companies are looking for in roles like solutions architect or ML engineer right now.
Definitely high demand skills.
Yeah.
Okay, so here's the final provocative thought we want to leave you with. It connects back to those ethical and learning components we discussed. Since Agentic AI relies so heavily on that continuous learn cycle, that data flywheel, the system is constantly adapting its behavior, right?
Right. So the real question for certified professionals isn't just about deploying the system initially. It's about governing its ongoing evolution. Think about it. If an agent learns and adapts continuously for 2 years, the entire validity period of your certification, how do you actually guarantee that the safety, ethics, and compliance guardrails you embedded on day one, how do you ensure they remain effective, that they aren't unintentionally circumvented or just sort of decayed by the system's own organic evolution over time?
Wow, yeah. That's a significant governance problem. It demands continuous oversight, doesn't it? Not just set and forget.
Exactly. It's a challenge that extends well beyond the initial deployment.
And that governance challenge, that's really the future of the field that you, our listener, are stepping into by pursuing this certification. We definitely encourage you to explore those structured learning paths, use effective practice resources as you prepare to take this really essential next step in your AI career.
Good luck with your preparation and happy deep diving.